So we're interested in connecting hybrid networks together. And if we're only interested in connectivity, we don't really have a problem. We can always, throw a GRE tunnel up or some kind of IPsec VPN or just extend some kind of overlay between our hybrid networks. But it really goes beyond connectivity. So what am I talking about? I'm talking about networks that were built for different purposes, different centers of gravity. They have different requirements and they care about different things. But when we're talking about a business, a lot of time those networks have to be connected together. And it's that glue, that point of integration that really tends to become really complicated. So the real problem we run into is when we're connecting different kinds of networks that are just different. So it's that boundary really where the assumptions about our architecture collide, that the real complexity of network architecture, network design, network engineering is going, kind of in the modern time. Consider the kind of traditional enterprise data center as an example. It's built for reliability, it's built for consistency. The workloads tended to be put in place and kind of left there, and our networks tend to be very static within the traditional network enterprise data center, right? Then we started needing some flexibility, especially around movement of the virtual machines and just being able to move workloads around inside the data center. And that's when we got things like, ACI and Apstra and just, BGP, EVPN, fabrics, VXLAN in the data center. That's when we started doing overlays in the data center to provide maximum flexibility in terms of workloads. But that actually gave rise to a different kind of network ultimately, which is like cloud networking, right? Where cloud networking, of course, is a different philosophy entirely, where we are outsourcing a lot of the management and the complexity to a third-party data center, which, the cloud. So whether that be public or private, but in this case, we've kind of talked about private. So I'm moving on to public. So in a public cloud, we deal a lot with the idea of abstraction of complexity, but also abstraction of control. And so the other thing we have besides control is agility. Agility is the most, kind of the big thing that the cloud kind of offers us. The ability to spin up and tear down workloads, move them. And, in order to support that, cloud networks have to be just as agile, but also, lack a lot of the complexity, but also a lot of the control that you expect from a data center. So that's kind of a different philosophy for a network. And then what we're seeing now is neo clouds or AI data centers. They're really built for speed and throughput, of course. But interestingly enough, the kind of the prevailing thoughts, I guess, or the prevailing designs as of right now for AI data centers tend to be kind of the NVIDIA specified model where you have a front end data center that is connectivity to the rest of the network for ingestion of data or just general connectivity. But then you have the back end kind of walled garden GPU network where really it's about extreme speed, extreme throughput, absolutely no latency, loss, jitter, no hiccups that can, that are kind of existential threats to AI workloads. So you have this new network that's really kind of two networks that have been merged that kind of, serve one function but do different parts of the same function with these neo clouds and these AI data centers. So these aren't variations on one network, right? If you abstract things highly enough, then it all works out, right? If you say, oh, well, a network is about connectivity, then yeah, I guess every network is the same. But really, what we're really talking about is three philosophical differences in networking, but also how we treat the data and the applications that are on our network, right? So, again, on the enterprise model, whether it be traditional enterprise data center or it be kind of new fabric data centers, the applications live on premises. They live, again, either on physical servers or on virtual servers or virtual hosts. whether they can move or not, whether it's a fabric or not as important. We're talking kind of philosophical design, where the app exists and people come to the app or they come to the data, and they're kind of outside of the data center block, if you will. So it's kind of we are static, we're here, we move around a little bit, but you're coming to us. And then with the cloud, it's more like you're going to there, because this is an outsourced third-party environment. Now you end up putting, enterprises end up putting some mixture of critical workloads in on-premises and then in the cloud, and we're already seeing our first hybrid networks because of that, right? But the cloud, again, philosophically, is not about what's in it. It's about the management philosophy. So if you put something in the cloud, it needs to be agile. It needs to be fault tolerant in a way that you generally don't think about it on the data center side, which is to say, fault tolerant between regions, or fault tolerant between, availability zones, or, whatever your cloud of choice calls it, but also built to more or less independently operate. So a lot of data centers like this kind of active standby, whereas cloud really is engineered, and kind of best practices are built such that everything's kind of active, or there's just, there's essentially ships passing in the night. They're two different applications, but a load balancer up front is taking care of farming that out. And then we have the AI / neo cloud, the kind of the new AI data centers. They're being built with completely different traffic patterns, right? Like their main goal, front end, of course, again, is more about connectivity. How do we get the data into AI inference models AI models, so we could do inference, and that piece of it, all the inference, all the training, all the super heavy math computational stuff, and quorum and all of the inference stuff between the GPUs is on the back end, and on the front end is really about pulling in or pushing out data, the results, or the training data. So again, in that case, it's a completely a different philosophy about, because we're not even talking about users really. Like there's not really necessarily users doing, like the back end, there's no users at all, right? It's completely AI. So again, very different design. So what that means for architects though, and this is the part I kind of want to get to, and I don't intend to just take a huge amount of time. I really just want to kind of put this out there, see if people are thinking about this, and see if people are interested essentially in what this means for network engineering and network architecture and design. Is that we're not as architects designing a single network. I mean, we are kind of, but it's really a network of networks, if you will. And a lot of the complexity is going to be in when we connect these networks together, and we're already, this is not new, right? We've had the cloud for many years now, and already many architects have seen some of the pain points of integrating a hybrid network from the cloud to on-premise. Now let's throw this third thing in there, where we're talking about some, neo cloud or AI data centers, and we're really talking now about integration between a lot of different networks built to different purpose that have different data, but all of it has to more or less move around, and everything kind of accesses everything. So this is the new challenge, beyond simply building like an enterprise campus and data center right now, or just building a cloud network, or even just how do we connect as simply as possible an enterprise to a campus, to a cloud. We're throwing in more and more complex and differently purposed networks, and then the architects are trying to figure out, okay, well, what's the common integration? How do we bring these things together? Because not only are they designed differently and do they serve different purposes, but the requirements and the kind of the careabouts, or what matters to a specific network, differs, right? So it's not even as simple as, hey, let's make sure the QoS matches up, the quality of service or quality of experience between all of these different workloads. We're really talking about something even more existential, right? Like, each of these is its own island with its own integrated kind of purpose, again, to not to harp too hard on that, but really they're built to serve a function, and each one of them serves a different kind of function. And we'll see, there's other networks out there too. There's other services, like we haven't even talked about SaaS or what that looks like. And it's, to be honest, it's a little bit more kind of around the elbow and out the door, speaking specifically of SaaS, but it's another integration that we have to think about. So what I'm finding that architects are really struggling with lately is not how do I build a data center, or how do I follow best practice to build an enterprise campus or a cloud network. Where they're really struggling, and where a lot of the vendors are not stepping up because they only know their own product, is the integration piece, right? So not only how do I connect this stuff together, but how do I make sure that data doesn't become a second-class citizen on someone else's network, if that makes sense. And that's really, I think, where the struggle is going. And I think it's going to be up to the business to make some of those calls, because that's ultimately it's business requirements that are going to determine which way we go. So I wanted to get that out there. It's something I've been kind of kicking around, rolling around in my head. And I want to see if other people are thinking about this, or what other people are doing, or, are you already trying to figure this out? Let me know. Thanks. I'll see you guys later.